Hello, Mr. Wilford here again, and I just wanted to go over um, what we're going to look at here in week 2 in geometry. We are going to take a look at chapter 1, sections 4, 5, and 6. And again, we continue talking about some of the fundamental things in geometry, just some terminology and things like that. When we take a look here in section 4, we're talking about pairs of angles. And again, I'm just going to kind of briefly go through each section here. Um, I'll remind you again that on the right-hand side of your online textbook, there's all sorts of good things for each section. So make sure that you take a look at some of these, especially some of the videos here. And then when you're done with the section, it's a good idea to take this interactive practice quiz. So just a couple of things, reminders there for you. Let's take a look and talk a little bit about pairs of angles. When we talk about pairs of angles, we have, first of all, what are called adjacent angles, and these are two angles that are up next to each other. They're kind of side by side. So two angles in the same plane with a common vertex. Remember, the vertex is that point where the two rays meet, and a common side. So as an example here, we have angle 1 and angle 2, which are adjacent angles. Then we have what we call a linear pair of angles, and this is where two of the rays are actually forming a line, and then we have another ray in there that would create two different angles, so angle 3 and angle 4. And so there are going to be some examples and problems that you're going to do that will involve pairs of angles and taking a look at some of this terminology that goes with that. Then we have what we call complementary angles and supplementary angles. With a complementary angle, then we're talking about two angles that when we add those two angles together, we get 90 degrees. It has a sum of 90 degrees. Supplementary angles are two angles added together that equal 180. So complementary is 90, supplementary is 180. And again, we're talking about adding two angles together. The sum is 90 and the sum is 180. But it's important that you understand the difference between there and those two angles, and try to remember complementary is 90, supplementary is 180. Again, you have a few examples that you're going to go through in this section where you're going to use the complement and supplement idea, and some of it again involves some algebra, so make sure if you have questions with that you let me know. Solving some of those variables in some of those problems. There are actually some good problems, and they're pretty straightforward. You just have to kind of understand the process, the steps that they take algebraically. But again, if you have questions, let me know. Moving on then, there's an example here where it's a good problem-solving application where they talk about light going through fiber optics. It's a good one. You can take a look at that. And then one thing that they talk about, another term here, is called vertical angles, or two non-adjacent angles formed by two intersecting lines. So angle 1 and 2 are what we call vertical angles. They're kind of opposite each other. And then we have angles 2 and 4. Those are vertical angles as well. So a lot of times in geometry we pass a couple of lines together, and we talk about the angles that those lines create. So it's important that you understand, again, the angles that we're talking about. Then again, we have some problems here for you to look at. Make sure that you look online for that assignment here for section 4. Let me go on then to section 5 and talk briefly about that. Using formulas in geometry, of course, there are a lot of formulas out there. We want to make sure that we understand what formulas and things have those formulas down and what they apply to. And this is where really you can use some practical applications for geometry. When you talk about the perimeter is the sum of the length sides of a figure. So whenever you measure outside a geometric figure, you're measuring the perimeter. Typically, perimeter is going to be your unit length, okay, distance around. You can think of it as measuring a fence. How much fence would you need to fence in your backyard, for example? You'd need to know the perimeter. Then we have the area. The area of a plane is talking about the space that a geometric fills up. Okay, so we have perimeter and area. A couple of important formulas here. And again, you've probably seen some of these before. Perimeter and area of a rectangle. There are the formulas here. It has to do with length and width of the rectangle. If you have a square, remember a square, all four sides are the same length. So we have, they just use S for one of the sides. And then we have a couple of formulas for the triangle, perimeter of a triangle. Because all three sides can be different, we just add up A plus B plus C. And then for the area, 1/2 base times height. So we have to know a couple of things about the triangle here. 1/2 base times the height of the triangle. And we go into that a little bit more here as far as the base and the height. It depends upon what kind of triangle you're talking about. And we'll talk more about triangles later on in this class. But we have base and height, base and height. It depends upon the triangle that you have, so be careful with that. And then we have some problems using those formulas. Those are some pretty common formulas, so hopefully you've seen those before, you know how to use those. In terms of a circle, we have a couple of terms here. When we have a circle, we have the diameter, which is the measure all the way across through the center point. We have the radius, which is the distance from the center point out to the edge of a circle. And then we have the circumference. The circumference is the distance around. You can think of it like the perimeter of a circle. What would the distance around that circle be? And formulas here, circumference and area of a circle. Circumference is equal to pi times diameter, or 2 pi r, 2 times pi times r. Remember, pi is a irrational number. Usually you can find it on your calculator, 3.14. The area of a circle is pi r squared. So you have to take pi and then the radius times itself, or r squared. For most of the problems here, if you use 3.14 for pi, that's fine. Or if you want to be a little bit more accurate, you can, of course, use your calculator. Some problems here using those formulas. And again, those are important formulas: perimeter, circumference, and area for all of those geometric figures. Very important and very common and good formulas for real-world application problems. Then again, we have exercises for section 5. Let me go on to section 6 and talk about that a little bit. We have here the midpoint and distance in the coordinate plane. Again, we're going to talk about some formulas here, so you want to make sure you take a few notes. The coordinate plane basically is your XY axis, and it's set up so that we have the X going left to right, the Y going up and down, and we have where they meet, where they intersect, is the origin. And positive x-axis goes to the right, negative x-axis goes to the left, positive y goes up, negative y goes down. And we have a couple of important formulas here that you want to make sure that you have down. The first one is a midpoint formula, finding the midpoint between 2 points, or the midpoint of a segment. And it has to do with basically adding your x's divided by 2, adding your y's divided by 2. So let me go over that again. You have to know point A and point B, and to find the midpoint, you have your coordinate, x comma y for A, x comma y for B. Basically, you need to add the x's, divide by 2, add the y's, divide by 2, and you will get your midpoint. Okay, remember now, the midpoint formula is going to give you a midpoint. It's going to give you a point. It's not going to give you one number. It should give you 2 numbers. So the midpoint is going to be an x comma y coordinate that you're going to get out. Okay, so make sure you understand that. And we have an example here that you can look at. It's really easy math because you're just adding the x's, adding the y's, dividing by 2, and then getting your midpoint. Then we have the distance formula. The distance formula is another important formula that you want to make sure that you get down. This one's a little bit more complicated, but basically we're finding the distance between 2 points. Okay, the distance of a segment. And it has to do with your coordinates of your endpoints again. Okay, so remember you have, for example, an endpoint at A and B, and basically this time you're going to subtract your x's and square it. You're going to subtract your y's and square that. Then you're going to add them together, and then you're going to take the square root of that number, and you get your distance. Okay, so make sure you look at these examples here and kind of follow along. It's important that you write these steps out. Don't try to do too much at once, and make sure you do it in the right order. So I'm going to subtract the x's first, subtract the y's. I'm going to square each one of them, then I'm going to add it together, then I'm going to take the square root. Okay, it has to be done in that order so that you get the correct distance. Now, you can see here they get like an answer to the square root of 29. That's fine. If you have a calculator, I would suggest even taking that a step further and getting a decimal number for that. Okay, take the square root of 29 on your calculator and getting a decimal number, because the decimal number actually makes more sense to me than the square root of 29. I mean, if you said, I'm going to go to this other town, for example, I'm going to drive to this other town and it's the square root of 29 miles away, you know, people wouldn't know what you're talking about. So using a decimal and approximating that square root is fine. Okay. A couple of other examples here in terms. In a right triangle, we have legs and we have a hypotenuse. This is the Pythagorean theorem. You've probably heard and seen this before. When we have a right triangle, we have a 90-degree angle, and we have what are called legs of a triangle. A and B are the legs. Those are the two sides that make the 90-degree angle. Those are called the legs, and then we have our long side, which is the hypotenuse. And there's a theorem that goes with that. If you take a squared, if you square a, and you take b squared, and then you add them together, you get c squared. Okay, it actually has something to do with the distance formula as well, but basically the Pythagorean theorem is a good one because it has to do with the legs of a triangle and the hypotenuse. A squared plus b squared equals c squared. And it's a pretty easy formula to remember, but it can also help you find the distance between 2 points. So make sure you look at that example as well. All right, another application problem here, and then we have problems that we're doing. Again, just to remind you, make sure that you look at some of these videos, these lessons here. Very good stuff and important. Practice quiz here for this section as well. If you have any questions, let me know. A calculator is always helpful. And then we'll end this week. We'll do sections 4, 5, and 6, and then we'll end this week with another quiz, just like we did last week. If you have any questions at all, please let me know. Thanks, and have a great week.